Hello everyone and welcome to another lesson of computer interaction. In this series of lessons, we're going to be covering how to create a mobile applications, uh, how to create mobile applications utilizing the Android platform. Now, in order for you to be able to program against the Android platform, first we have to know the basics and some little history about the Android platform itself. Then we're going to talk about a little bit more about the Android stack, about how your application is being compiled and everything. Okay, so without further ado, let's jump in and talk about what is actually Android. Now, Android is an open source operating system built by Google, okay, for mobile phones and tablets as well as media players. It has appeared as well on many game consoles as well, which is quite interesting. And it's in fact was developed by Android Incorporation. Then Google in fact acquired it, and then they have been secretly working on it, working on Android itself. Then later on, somewhere in 2007, 2008, they started releasing the first Android version of the operating system. So when Google released the Android project itself, they released it as an open source project under the Apache license, under the name of Android Open Source Project, and you can develop Android applications using C and C++. Now, some of you have been wondering about the three pictures down there in this slide here, and like this one, and this one, and that one. Now, of course, this one maybe is the most obvious. This is actually the Nexus series, which is, by the time of this recording, is being, that Google is actually being, like, how can I say, supporting it, or Google is giving the most love to the series of devices. They get always the latest, greatest updates whenever Google just starts releasing a new Android version or a new update to the operating system. However, if you look on this is the phone, and this is, by the way, this is like, I think this is one, there's a Nexus 4, Nexus 7, and Nexus 10. By the time of the recording, they are the latest, greatest. Actually, Nexus 5 has been released already a long time ago, but these are the latest, greatest uh, Google devices, let's say, that you can purchase them from the Google Play Store. On the other side, here and there, this is Ouya, one of the most interesting projects, and one of the most interesting gaming console. That's the first gaming console released based on Android, and it's a fascinating gaming console actually, and it's quite cheap actually for the technology which it offers. It's actually quite cheap for basically for any game console. I mean, most gaming consoles they cost at least $400 or something like that. This one costs at least $99 on their market. And they have their own application market, and you can download games and you can play them and everything. It has a joystick. It's really amazing gaming console. The other one, on the other hand, here is the gaming console released by NVIDIA. It's called NVIDIA Shield. By the time of this recording, is NVIDIA Shield 2 has been released. And it's also quite fascinating technology. NVIDIA has actually, NVIDIA Shield 2, by the time of this recording again, have integrated the NVIDIA Tegra K1, I think, chipset in there. So you get the latest and the most powerful mobile graphics card on this piece of technology, and it actually can stream full HD 1080p directly to your TV, so you can play your games and stream them directly to your TV, or you could even stream directly from your PC to your gaming console in full HD and everything in this small screen. So you can actually play your game on your PC, but your PC just simply streams the pictures to your, or the series of images, the renders to your gaming console, and you can actually play the game wirelessly, which is actually excellent. Now, of course, you have Google TVs, which is, I think, made by Sony and Samsung, so you can actually even have your own Google TV, which is quite tethered and hooked up correctly and everything with your mobile with your mobile devices, whether it's a tablet or it's a phone. So you can use your phone as a remote control, which is kind of fascinating as well. All right, so this is basically a very quick introduction to Android here, what is Android is about and where it actually runs. Here is a little bit of history. So in 2005, Google buys Android Incorporation. 2007, Open Handset Alliance is announced, and Open Handset Alliance is a series of actually is a collection of cooperation between huge companies and 80 something companies, actually if not hundreds of companies, that are actually supporting the Android platform. Among them is HTC, Sony, maybe Sony, Samsung, and Motorola, and many others. By 2008, 2010, Android becomes a quite dominant mobile platform. In 2011, Android started to invade the tablet, game console, and TV market. And by the time of this recording, 2014, Android right now is actually the most, according to the reviews and economists' reviews, right now Android is the most dominant platform on the mobile market. It's actually overthrown the iPad in terms of the market share just actually quite recently. So this is a very interesting fact here. Who knows? God knows what happens, I don't know, after this recording. But by the time of this recording, this is what is the state of the Android according to the economists and the reviews on the internet. So what do you need to develop for Android? Now, before Android, Android basically, in order for you to develop for it, you need just any operating system. So Windows, Linux, and Mac, it will work fine. So if you are a Mac, or you're a Linux guy, or girl, actually, you can actually develop on whatever operating system you want to. However, for this course currently, since I'm running a Windows machine, I'm going to be developing on Windows. However, you shouldn't have any problems developing or following these lessons on any platform you are using. All right. There are many IDEs that support developing for Android. You have Eclipse, which is currently the most stable, I think, the ADT bundle. We have NetBeans, and I actually have heard people they could tweak NetBeans to work with to develop for Android. However, I don't know how successful it is or how easy it is, but because I haven't even touched it. And Android Studio. And during these lessons, we're going to be using Android Studio. Now, Android Studio has been released in Google I/O, I think, 2013. And it's a quite interesting, how can I say, IDE, which is the most probably going to be the main IDE for developing for Android. However, it's still under construction and still under heavy development and under heavy changes and everything. So if you are doing your business, building up your business or something really serious and solid, maybe Android Studio wouldn't be a very good choice. I mean, Android Studio is currently, I've seen people have been developing using Android Studio for real business, and they are doing real projects out of it, and it works fine. But I don't know how large your project is, so just be careful when you make your choice. There is an ADT bundle, which you can download from the Android developers website, and you can actually start developing using this plugin. The Android development plugin, the ADT plugin, which is built on Eclipse. So you can use that as well. However, officially during these series of lessons, we're going to be using Android Studio. And please, whenever you install the Android Studio, just once you install it, try to update it to the latest version and everything, patch it, and then you're going to be fine. You need, of course, Android SDK installed, and we're going to explore the Android SDK folders and everything so you can see what kind of tools it offers. And during the series of these lessons, since I'm recording the videos here on the computer, I'm gonna need actually to show you the results. So I'm gonna be using an emulator. However, it is very, very highly recommended that you use a real Android device for real development. Otherwise, you won't be able really to publish your game or to publish your app on the application store. Otherwise, you can develop and everything, the application on the emulator first, but then if you don't test it on a real phone and then you throw it out on the application market, you most probably going to see a lot of problems people are reporting it due to that you haven't in fact tried your application on a real device, because on a real device you get a lot of um, things could appear on the real device that they haven't appeared on the emulator, because at least the emulator is much it could be much faster than your phone, since your PC is much more powerful than your phone, obviously. Okay. Now, for your Android device, in order for it to communicate, I mean, in order for the IDE to communicate with your Android device, actually, you communicate with your Android device using something which is called the ADB, or the Android Debug Bridge. This is a command line tool that allows you to communicate with your Android device, and this is the only way for a developer to communicate over an Android phone with the device officially, of course. I mean, if you would like to develop your application, you start debugging and running your application, you have to use this ADB or the Android Debug Bridge. And I will, in fact, copy this link and show it to you. By the way, this is the, all right, there you go. Just let me try to fit in this browser into the recording screen here. Oopsie, a second. There we go. So this is, well, okay, this is right now by the newest kind of, flow, and by the time of recording, we have Android KitKat. I don't know by the end of the series, well, how many Android versions and patches will appear. But anyway, we have the Android Debug Bridge, and right here you get the full command line help. By the way, the developer.android.com should be your bookmark it, make it your homepage, do whatever you can, because this is one of the most magnificent documentation for an SDK I've ever seen. I mean, there's MSDN, which is very powerful and amazing. I think if I rate them, I'd say MSDN. Then comes next the developers.android.com. I mean, the Android's documentation, the online documentation by developer.android.com. There is, I don't know about the iOS, honestly. I've touched their documentations a little bit when I was trying a little bit of iOS. They have it really good, but since I haven't really went deep in there, so I cannot judge it, but because I was working mostly with the Android documentation, I can really tell it's really powerful. Okay, so this is the series of commands which you can use in order to communicate with your device, whether it's a physical or emulator. All right, so whenever you are trying to communicate with your device, whether it's emulator or a real device, you have these command lines which you need in order for you to install your application and debug it. Okay, in fact, when you hit the run command, like when you compile and run your application, a series of these commands are being executed for you by the IDE. So, for example, the IDE first copies your device, copies the APK file, which is your application file, to the device, and then runs the installer, and it installs the application on the device, whether it's an emulator or a real device, and then it runs the application for you, which is really quite interesting. So so yeah, without an ADB, you cannot actually work anything. And you have the if you actually don't like to hook your Android device using a USB to your PC, there is an ADB wireless. Before KitKat, I think you need to have KitKat on your phone. Before KitKat, you had to root your device, and then you could debug wirelessly. So but of course your PC and your phone has to be on the same network. So you activate the wireless network on your device and make your PC just simply communicate with the device using the ADB. You have to run the command line and just simply say ADB connect, and then you connect to the IP address of your phone and the port number, which I think it was 4.5s, the default port for ADB bridge. And then you can just simply run and install your applications, debug your application wirelessly, which is really great. If you have KitKat, you can, without rooting, do the same thing as well. Okay, so let's move forward. And let's talk about the Android versions and their APIs. Now, by the time of this recording, as you can see here, this is the table which I've copied from the Android developers website, the dashboard website, the dashboard page actually. And as you can see here, we have four columns here in this table, very important columns in this table. The version number, which is maybe it's good for you to know as well. The code name is mostly popular with the developers and non-developers. So most of the time, people walking on the street, even though they are not developers, they're talking about the KitKat Jelly Beans. Maybe they're remembering the versions. However, for you as a developer, you have to be careful and be knowledgeable about the API number, because this is what you should care about. All right. Because most of the time, when you are actually not most of the time, you are always, when you are working in Android, and from the IDE point of view, when you are just typing the code and everything, you're gonna get errors, for example, or warnings about using deprecated functions that has been, for example, erased or had been deprecated from newer APIs, and you have to go to the older API to use them, for example, or something like that. So, for example, if you would like to work with KitKat, you have to specify, and you say in your Android manifest, and we're gonna see what an Android manifest is once we explore the project structure. You have to type in, I'm working with, well, yeah, I'm just saying in plain English, I'm working with the API version 19. So target SDK equals to 19. And then immediately the IDE or the compiler, let's say, recognizes and say, okay, I'm going to be using the libraries from the 19th API 19th version. All right. And the distribution column here, it tells you about how many people are using the current platform. So, for example, by the time of this recording, only 1.3% of people who have Android phones, they are running Froyo version 2.2. 20% are running Gingerbread. Honeycomb are 0.1%. All right. And then when you come to ice cream sandwich, 16.1%, jelly beans, 35.5%. And of course, you can sum this all up because there have been like 1, 2, 3 iterations. I mean, okay, 2 iterations because the first iteration was jelly beans. So the second, you have 2 more iterations on jelly beans, which has been a lot of bug fixes, introducing a lot of features, and so on. And then the Android KitKat, which has been recently released by the time of this recording, so that's why it's 1.8%, and of course it's still rising. Now, why you need to know about this distribution? Well, if you would like to target a specific platform, like right now I'm actually writing an application and I would like to reach the mass market, and I would like to reach as much devices as possible. So you will say, okay, you always target the latest greatest, so you have to program for the latest greatest Android phone, and then you have to go back and support older devices because not everyone is being updated, or not everyone is updated to the latest version. There are still people who are left behind. So you're gonna have to support up to some certain older platform. So you say target SDK is, let's say, 19. Target API is 19. And then you say minimum SDK version is going to be, for example, 15% on API 15. And then now when you look at it, 16 plus 35 plus 16 plus 8.9 plus 1.8. I mean, most of the time you'll be probably going to be covering like 30, 65. We're talking about 75% of some sort. Yeah, some sort, like 75% of the market. If you go ahead way back to the supporting Gingerbread, right now you're going to be supporting almost 90-something% of the market. And there's, of course, I mean, instead of summing this up in your head and everything, there is Android dashboard, which you're going to see in a moment, which shows a huge graph or nice pie chart showing you what is the distribution of users, how many of them are using certain operating system, which will help and assist you in decision which API version to support the minimum. By the way, once you go to the minimum API support, you will run, for example, into problems. You cannot use always the newest features. You're gonna have to fill back to use some certain older features. If your Android phone, for example, you're gonna have like you could write the code. Let's say, for example, we could write the code twice. For example, one if the Android is the newest version, so we're gonna use this newest function. If not, we're gonna use the older way of doing things, since you need to support both of the older and newer ones, or newer APIs. I mean, okay. All right, so let's talk more about the Android stack. Now, if you look carefully, we have some sort of like 1, 2.5, 3, and 4, like kind of sort of levels of stack in this Android operating system. The first one is the Linux kernel, which comes in the bottom right here. And in the Linux kernel, I mean, Android is using the Linux kernel for the base of its operating system because for several reasons. First of all, we know, I mean, the Linux kernel is open source, and we know its security, how can I say, security model. So you could, so you could actually even strengthen it more. You can protect it more, so it's a little bit more secure. Linux kernel as well is the driver. We know already the driver model of the Linux kernel, and this is really good. And you can see the reflection of that knowledge of knowing the driver model on how Android is running on different platforms. So you have Android running on your phone, Android running on your tablet. Android is running on gaming consoles. Like people are making devices, and running it on gaming consoles and on TVs, so that you can actually make devices, and then you can, since you know already the driver model of Linux, or sorry, the kernel of Linux, and then you can apply that to your hardware, which you made, and then you can start selling your devices. All right. This is, in fact, the philosophy of Google when it comes to Android. They want to run Android on everything. They want to run Android on your phones, on your tablets, on your gaming consoles, on your TVs, on your fridge, on your washing machine. They want to use it everywhere. This is the fight of the ecosystem. They want to make a fully compatible ecosystem that once you get in your house, you are completely plugged in, and everything is in sync. So you can imagine like your house, maybe in the future, you walk inside the house with your phone, and then you get your fridge immediately reporting to your phone, okay, we are missing this, you are missing a little bit of milk, you are missing eggs, you are missing, I don't know, cheese, for example. The washing machine, for example, says, okay, the washing has been done, you need to, take out your clothes to the dryers, and so on and so forth. So this is what the people right now are thinking about, making an ecosystem based on a certain platform. And this is why Google actually used, for example, the Linux kernel. Okay. So of course, as you can see here in the Linux kernel part, you have basically the drivers. So the camera drivers, keypad drivers, the Wi-Fi drivers, and so on and so forth. Above the kernel right away, you get the legacy, some sort of legacy libraries, which allows you to interface with let's say, with the kernel. For example, OpenGL ES, let's say, it has to be right here because actually OpenGL ES stands for embedded systems. So you have a minimal version of OpenGL, more or less, which can interact directly with your video card. So with the display driver right away. So it interacts directly with the video card. So you see where it stands. It's very close actually to the hardware. So that's why it's actually quite fast. SQLite, which is the database engine, which is or database management system, which even your phone contacts, your SMSs, and all these stuff are being saved in there. WebKit, for example, is the default rendering engine for the web browser, for Chrome, let's say. And yeah, so and libc, for example, is the library which allows you to program against the phone with C, C++, and other things as well. Okay, so the Android runtime is right above as well. It's right inside, within, or maybe above the libraries. And and there are two very important things here: the call libraries and the Dalvik virtual machine. And we're going to talk about it in the next slide. The application framework, and the application framework is in fact your API version. So whatever is in here is actually this thing, this column, okay? And this application framework is a bunch of libraries, a bunch of features, which allows your application, which you program, which sits right here, to interact with the whole system. And by the way, the Android stack, in terms of security, the kernel has the final say to allow you whether a certain thing will happen or not. So accessing system files and everything is actually the kernel's decision, which makes it powerful, because right now they took out they are not relying, for example, on the Java security part anymore. For example, like I think like the BlackBerry's platforms, where you have where they are actually relying only on Java, and they're relying on Java security model. Right now, they left the security part to the operating system and the kernel part, So you don't need to worry about most of the time about the security model of Java and everything. So anyway, whenever Google introduces a new API version, it actually introduces one of these, let's say, bubbles, or one of these, how can I say, squares or rectangles or features. So a new API release, you get more of those. And your application, which sits right here, could interact with the application framework. Okay, so how your application is compiled. Now we can compare the application compilation process. This is the classic Java, and this is your Android application. Now your classic Java code is usually being compiled into the Java bytecode, and then from the Java bytecode you get the .class files, which runs or executes on the Java virtual machine. Okay. Now this is quite easy and straightforward. And of course, Java Virtual Machine contains the just-in-time compiler, which executes parts of the code which are used in runtime. So if you are invoking a certain function, it just gets converted. It just gets converted into machine code, and then it runs right away. Not the whole application being converted into the machine code. Okay. So the same thing comes over here, almost on the Android side. So you have your Java source code converted into the Java bytecode, and then from Java bytecode you are getting converted into the Dalvik bytecode, and then from the Dalvik bytecode you get the DEX file, which runs on the Dalvik virtual machine. Now here's the question: what is Dalvik? Dalvik is the Java runtime or Java virtual machine made by Google in-house that allows your Java application to run on mobile phones much more efficiently. Google found several problems, huge problems with Java virtual machines. First of all, they are quite heavy on the system. They are demanding a lot of resources and a lot of CPU power. Maybe you could even lose more battery, which is really bad, because your mobile phone, in fact, has a small battery, and you need to survive, let's say, the whole day at least in order for you to do some certain business. And if your phone cannot survive, at least, let's say, if your phone behaves like a laptop, then the phone is completely useless, of course, because if your laptop does last for 3 or 4, maybe 5 hours, you need your phone to last more and more than that. This is one thing. Another thing, of course, they were trying to escape the licensing issues, because Java Virtual Machine, since Oracle bought Sun or acquired Sun, right now Google has to buy the license for distributing Java Virtual Machine on its phones. So this is one more thing to get rid of. So they made much more efficient, much better and faster virtual machine, Java Virtual Machine, that can run on your phone much more efficiently. Okay. All right. So the question here comes: why converting from Java source code to Java bytecode and then to Dalvik bytecode, instead of just going from Java source code to right away to Dalvik bytecode? And this is quite interesting. in fact, this feature allowed for interesting, let's say, actions or interesting technologies to come out. Right now, for example, you could program against Android using, let's say, C Sharp. So what happens here is, I think you could have seen, for example, Xamarin Studio, where you can program against Android, iOS, and Windows Phone, and other platforms using C Sharp, for example. So what happens here is your C Sharp code is being converted directly to the let's say the Delbert bytecode, and then from Delbert bytecode goes to the becomes a DEX file, and then it runs on your phone. So this is one of the very interesting feature that you get with such execution model. Okay. Now, by the time of this recording, Google have introduced the ART, the Android runtime, and since Dalvik actually is a virtual machine, is a Java virtual machine, it still has, for example, this just-in-time compiler, and it has to interpret in real time your Java application, convert it into machine code, and run it on your CPU. So this slow part in the middle, like it's still the middleman standing there to run your application. So the Android runtime uses the ahead of time compiler, which actually takes, whenever you install your application is completely converted into a machine code. So your application is still an APK .dex files being downloaded to your phone, and then your phone compiles this program which you have downloaded, converts it into machine code, which makes it much more efficient, faster, and even uses less processing power. You get longer battery lives, and you have even much faster phone. So this is really a great feature. However, by the time of this recording, it just has been introduced in KitKat 4.4 as an experimental feature. It's still under heavy development, and Google still advises not to use ART as your main runtime, because it can actually break some of your applications. So it's some of your applications. So it's still not fully tested. It's just released for developers to test it out and report to them, of course. Okay. Yeah. So this is regarding ART. So let's move on to your application and how it actually looks like. So your final application, when it gets compiled to an APK file. Your APK file is composed of several parts. The first part is your Dalvik executables, or Dalvik files, or DEX files. And then so DEX files plus the resources. So resources, we're talking about icons, images, whatever arts you are using. So these are called resources. All right. If you have a game, so it's going to be your textures, 3D models, and the other stuff. Plus native libraries, since you are actually using, since you could use C++ in order to develop for Android, there you can actually include all that into one project. So for example, if you are making a game, for instance, and you are programming, let's say, half of it in Java, however, you would like to have a little bit more fast and efficient, let's say, physics engine. So you don't want to use Java in there. You would like to use C++ because it's a little bit more lower level, and it can run faster. So you can have physics engine in C++ and your Java files for describing, let's say, your game. So you can have the C++ part plus resources, or the native library, plus resources, plus Dalvik executables, and it makes up the APK file. By the way, the APK file is more like a compressed zip file. You can actually open it with any archiving program, and you can see all this within the. You can open this APK file, and then you can see the contents of your application, which we're gonna see once we get into the development side. All right. Now, finally, here is the very, as you can see, I'm very stressing over here, very important links and resources which you really need to have or to know about. So let me copy this link. I'll go over here, And this is the Android dashboard. And again, by the time of this recording, this is how the distribution of users of the Android platform currently in the market. So, so data collected during a 7-day period ending March 3rd, 2014. Any versions with less than 0.1% distribution are not shown. So until now, Honeycomb is 0.1%, so that's why it's still shown. All right. So you have, as you can see here, if you support, let's say, Kit Kat, Jelly Beans, and Ice Cream Sandwich, you are supporting a little bit more over than 70, I don't know, 77% or 76% of the Android market. If you support back to Gingerbread, right now you are guaranteeing that at least 99% of the market will surely at least see your application and purchase it or download it, whatever. Okay. Now, because we have so many screen sizes right now, and this is what the people are talking about, the fragmentation of the market, and seeing it as a negative thing. By the way, fragmentation right now is not an issue in Android platform. It was before, but not right now anymore, because how the Android platform has been developed and has been updated and upgraded. Right now, nobody worries about too much about the fragmentation, and pretty much almost all platforms suffering from the same problem. I mean, if you look at the iOS side, which people were saying that they didn't have fragmentation, right now it has it. So you have the iPad with the different versions of it and different screen resolution, Retinas displays, and all these stuff. iPhones, they had Retinas before, and they didn't have. I mean, they had Retinas, they didn't have Retina. I mean, they didn't have one Retina displays. Right now, they have a version released with a Retina display, and right now has been released with a little bit larger screen, so you get at least 5 or 6 different screen sizes for iOS, for the iPad Mini Retina, for example, and all these, and iPad Air. So you get all these different screen resolutions. For Android, you get the screen resolutions with all flavors and screen sizes of all flavors. So on phones that are 3.5, 3, you have the smart watches, which are released by Samsung, which is, I think, 2.0 inches or something like that. So you get screen sizes of many flavors. And right now you have to be careful how you make your art. So you have to make your art, whatever your icons or your logos of your applications, has to appear nicely on all these screen resolutions. So that's why here it shows you I mean, how many people are using HDPI, XHDPI, and XXHDPI, and so on and so forth. Okay. Now here is the OpenGL version. Now for those people who are developing games on Android platform, this is highly important. Now you can see how many people are running devices that are supporting which version of OpenGL ES. Now, of course, if you would like to, do something really great and powerful, of course, you have to support. I mean, you have to use the newer features in OpenGL in order to get much better rendering effects and all these stuff. If you fall back to the older ones, then you're gonna get a little bit lesser effects and so on. And I think with the KitKat, the OpenGL 3.0 support has appeared, and you have OpenGL 2.0 is still supported by the huge mass of the market. So if you are at least supporting OpenGL 2.0, you're going to be hitting at least 90% of the market. So there you go. Okay. Now this is for the Android dashboard. It's very important for you as a developer to visit this before you start developing your project, so it will give you a lot of insights. Now, since we are doing human-computer interaction with the Android platform, you're going to have to consult all the time the design principles, metrics, style of the Android operating system, how your colors should look like, how your typography should look like. This is highly important because you need your device, you need your application to blend in with the device. Unless you are making, for example, a game which doesn't have any doesn't have any connection, maybe it doesn't have any connection, mostly with the operating system itself, because right now you have all the different arts and everything. I mean, mostly when you are running games like Assassin's Creed, for example, in your PC, let's say, it doesn't utilize the Windows kind of, let's say, operating systems idea of how, or philosophy of how the user interface is constructed. Right now, it's much more artistic. Okay, so this is something else. But if you're making an app for the users, try to follow the user interface kind of how can I say, rules or user experience rules that are being made and specified by the Android operating system to achieve the highest or the best user experience possible. Now, here you get, for example, I don't know, patterns, so gestures, how the gestures should be done, how the gestures are being happening according to the standards of the Android operating system. Okay, so for example, systems, metrics, and everything. And by the way, the metrics, you have to really try your best to get it exactly right. Because most of the time, I mean, the Android phones, I mean, any phone for that matter, they are really small screens and they are really closer to the user's eyes. And the user will really feel every pixel which could go wrong. So you have to really follow the metrics and follow how the user interface is being, you know, like laid out and everything. So this is really, really important. Okay. Moving along, and since everybody loves tutorials and everything, there is in fact a tutorial page on the Android platform, so on the Android development website. Building your first application, adding action bars, supporting different devices, and all these stuff. So you have a lot of interesting things going on here. Right here, once you would like to get deeper to the inside the operating system, or like to get deeper for developing an application in a highly advanced way. Right now you start playing with the activity life cycles, for example, and getting along with how starting activity, pausing it, how to retrieve data, restore data, for example, from an activity that you are, for example, leaving one activity, and then when you return back, it restores data, saving settings, and all these stuff. So this is the part where you should go to. And here's as well the packages which you could utilize in order for you to develop for Android. For example, let's say this is the Android Bluetooth, and it tells you what are the methods that are inside this Android Bluetooth, let's say class. And here, or namespace, for example. And here, for example, this is the Bluetooth class, and it tells you all the functions and methods and parameters, or class members that are available for you, so you can utilize Bluetooth as it should be. If you have time in your hands and you would like to make your own, let's say, some sort of Ouya and all these stuff, right now you have the accessory development kit. Now, for sure, I think Samsung have utilized it for their smartwatches, so you can actually make your own device and install Android on it and program it, and then this is it. You have your Android device, which you have made with your hand. And if you would like to, you can go ahead and buy, let's say, you could, in fact, ADK, as you can see here, there you go. The ADK 2012 is based on the Arduino open source electronics. So you can actually buy an Arduino board, which is there are a lot of models that are the size of the coin, of $1 coin or whatever, or 1 KM coin. So which you can actually purchase on eBay, and then you can, or any retailer, and then you can in fact install Android on it, and then you can start programming against it. Now, of course, here are the steps and the guide on how you could actually install it, compile it on your device. So it's really, really quite fascinating. If you would like to, make some sort of a fork out of the Android open source project, so you could, for example, make your own. For example, Kindle Fire is based on Android, and it is in fact a fork of this project. I cannot remember honestly currently I cannot remember exactly. Oh, actually, NVIDIA Shield and Ouya as well are based on Android. So this is a fork of this project as well. If you would like to make your own ROM, for example, you can actually use this open source project, and then you can make your own ROM and so on and so forth. Now, Googling and Stack Overflow, you cannot imagine how many questions has been answered on Stack Overflow and Google. So it's really amazing that how many problems you could actually solve if you are using one of those, I mean, Google search, of course, and Stack Overflow. Now, there are several books. I don't like reference books because they tend to be heavy and large and bulky, but there are some smaller books which are really good. Create Android applications by create Android applications developed and designed by Chris Hazeman. And there is Learning Android by Marco Gargenta. And Marco Gargenta, by the way, has a very interesting Android Bootcamp series on YouTube. Go ahead and watch it. It's really great. He's actually developing an ice cream sandwich, and he's developing, I think, a Twitter app. So it's really, really great introduction as well to Android. It's really, really great. And he starts from scratch, and it's really advanced and really deep. And for those who would like to develop for Android using C and C++, you have this website. So this link, the Android Native Development Kit, or Android NDK. And you can download it on your Windows machine, and then you can install it and use it according, of course, to the instructions here. Now, honestly, since we are not going to use NDK, we are not exploring that part of the course. But however, if you would like to use it, there you go. Here's the link. You have a lot of resources on the internet. I think as well, Marco Gargenta or maybe somebody else has in the same YouTube channel have already the NDK series. So if you are interested to use Android NDK, it's there. All right, so and of course, I mean, this is the official kind of pages which are quite interesting to see if you are developing for Android. There are many other websites and links to many tutorial web pages. For example, you have the Android Hive.info, and then you have, I mean, by the time of this recording, it's still there, and it is a really great website. Let's hope that I actually get it somehow. It's still, oh, okay, that's quite fascinating. Okay, it doesn't matter, but anyway, no, well, this is weird. Okay, let me see if I can. All right, guys, by the time of this recording, I lost internet connection apparently, so I'm really sorry about that. But anyway, AndroidHive.info is a really great website for you guys to look at. So please go ahead and actually like explore these websites, because there are a lot of gems are there for you to use in your applications. All right, so.